Alrighty, ladies and gentlemen. Here we are again today. Transformations of functions. Horizontal translation or a shift. Vertical translation or a shift as it's known as. Reflection in the X, reflection in the Y-axis. I think we're going to continue with those here today. I don't know if I'm going to introduce the other two new transformations here. I don't believe so, but we'll see. Maybe in the second video. All right, so let's do a quick little review here. Page 2. Number 22. Let's start there. And the directions is to describe the transformation used to get from f, the original function, to g. And we have e to the x is my original here. F of x. And g of x here is e to the power of x minus 4. So what is going on here with this transformation? Well, remember, people, you know, if you see a number, right, if you see a constant, right, a number, that's telling you that, you know, a shift has occurred. Now remember, to tell the difference here between a vertical and a horizontal shift, I say if the number is in with the x. Right? If the number is in with the x, that's a horizontal shift. If it's not in with the x, then it's, excuse me, a vertical shift. Pardon me. So, here in 22, the number is in with the x there. Right? So that is a horizontal shift. The number is in with the x. Now remember, the sign in a horizontal shift does not dictate the direction. It's like the reverse or the opposite. And minus 4 you would think goes to the left, but it does not. It goes right 4 units. And there's a couple reasons behind that, you know, as I explained when I introed it. You know, with the vertex of, I think it was x squared I used, right, was the original function. Right? 4, 0, right? 4, 0 would be, x would have to be 4, right? For y to be 0. Right, so 4 zeros to the right of 0, 0. You know, I'm talking about x squared, not e to the x. All right. Now, number 23, 23 here. You got e to the x, and then you got e to the x plus 5. Here, the number is not with the x, right? It's not in, right? It's not in with the x. This is a vertical shift. The sign does dictate the direction in a vertical shift. Plus 5 means it's going up 5 units. Up 5 people. Okay. All right, very good. Let me do 26, 27, and then we'll see what we got on the next page. 26 and 27, people. You see a negative there, right? You see a negative. All right, that's indicating that a reflection, excuse me, has occurred, a reflection. Okay. And remember, I go back to the coordinate rules. Right, x comma y here, and when you reflect over the x-axis, you keep the x, negate the y, right? And when you reflect over the y-axis, the x is negated and you keep the y. And remember, y is f of x. Right, so I can say negative f of x here. Doesn't look too good. And negative f of x. So a reflection over the x-axis means the entire function is negated, right? F of x negated. The entire function is negated. Whereby a reflection over the y-axis, it's just the x, right? It's the f of negative x is the general notation. I might get into that in a little bit. It's not the whole function, just the x's. You know, depending if you have like 2, 3 terms, you know? We might see that moving forward, but for now we just have one x. So if you look at 27, right, that's just the x being negated and not the entire function, just the x. All right? Just the x here, so that's a reflection in the y-axis, right? When it's just the x that is negated. And in 26, that's not the x, or just the x that is negated. It's the entire function. Right? Cosine of x is your function, and it's negative cosine of x. That's negating the entire function here, right? This is negative f of x. Which means y, right, is negated. I'm kind of going backwards here. Which is a reflection in the x-axis. So that's what 26 is, reflection in the x-axis. All right. Let me see here. Do I do the general? Did I include that page with the general stuff? I think so. Oh yeah, I did, okay. All right, so I'm going to take a little jump here just to kind of review this stuff. So this is the general form. So this is page 19. I just want to do the top here. Page 19, the top. And this is, you know, the general notation here. I know they use the number 8, you know, but I guess, you know, the true general form here would be f of x plus c, c being a number. So if you have f of x plus 8, and f of x is any old function, x squared, x cubed, or whatever. So you take any function, you do a plus 8 to it. What's happening to the graph there? All right, so if you start with the original function x squared, and now you do a plus 8, so x squared plus 8, what's happening to the graph there? It's a vertical shift, isn't it? The number is not, right? It's not in with the x. So this is a vertical shift 8 units up, people. Right? Sign dictates the direction, right, in a vertical shift. F of x minus 8 here, right? Another vertical shift. Number is not in with the x. That's 8 units downward. F of x plus 8 now. The 8 is in with the x. Right? The 8 is in with the x. That's a horizontal shift. Sign does not dictate the direction. All right, you would think positive is to the right. No, it's the other way. It's to the left. F of x minus 8 is shifting the graph 8 units. Horizontal shift, numbers in with the x. Sign does not dictate the direction. Here, negative is to the left. No, it's going to the right. 8 units. And now we have negative f of x here, which is negative y, right? Negative y. I'm going reverse again, which is a reflection in the x-axis, right? Negative y is a reflection in the x. And the f of negative x, it's just the x, right, is getting negated. That is a reflection in the y-axis. All right, so this is kind of like the general form here. You know, I'll throw the c in there, f of x, you know, minus c. This is the f of x plus c. The general form for your shifting, x minus c. C being a constant, being a number. All right, so there you go, right? Just kind of reviewing there, the shifting, the general form. Alrighty, let's go back now. Start, what was it? Page, this one? Yeah, page 3. Right. Graph each function without using a calculator. Draw all necessary points and asymptotes. All right, so, you know, let's try to do this, you know, without a calculator. X minus 4 quantity cubed. So, you know, what am I thinking about here? You know, in terms of how to graph this without a calculator. Well, this is a transformation of, you know, the original function here. That's y equals x cubed, right? If you have y equals x cubed, and then y or f of x equals x minus 4 cubed, so what's going on? You know, what's going on here? This is a transformation of y equals x cubed. The 4 is in with the x. horizontal shift. All right, so this is going not left, right, but right 4 units. This is a graph of y equals x cubed shifted to the right 4 units. You know, so think about those points, right? Think about the points on x cubed. Right, remember we did it the good old-fashioned way, table of values, yeah? 0, 0, right, is on x cubed. Let's move that to the right 4 units. 1, 2, 3, 4, right, to 4, 0. 1, 1 is on x cubed. We're going to move that to the right 4 units. Right? 5, 5. 2, 8 is another point on x cubed. Move that. Right? Move that to the right 4 units. Right? 2, 8. Move it right 4. 1, 2, 3, 4. Right? There you go. All right. And we do know some other points, right? -1, -1 is on x cubed. Move that to the right 4 units. Right, -1, -1. Move it right 1, 2, 3, 4. And then -2, -8 is another point on x cubed. -2, -8. Move it to the right 1, 2, 3, 4 units here. You know, you could graph the original on here if you wanted to. Right, I'll make this in blue, right? You want to graph x cubed. Right, so dark blue here is x cubed. Right, you can plot those points and then, you know, just move them right 4 units. You know, you could do that if you wanted to, right? Graph the original. And then work off of that, you know, to get the points of the transformation. So, you're just saying. And then we graph it, right? So there we go. The red here is the graph of x minus 4 quantity cubed, people. Already? All right, let me stop here.